Every time we lift our eyes to the night sky, we are not simply observing space. We are witnessing music, history. Light from distant stars has traveled for thousands, millions, even billions of years before reaching us. What we see is not the universe as it is, but as music it once was. And for most of human history, even that view was incomplete. Two immense barriers stood in our way. Vast clouds of cosmic dust concealed entire regions of space, while the expansion of the universe itself stretched ancient music light beyond the limits of human vision, shifting it into music invisible wavelengths. The earliest stars, the first galaxies, the true origins of cosmic structure, all of it remained hidden, locked behind veils we could not pierce until one moment changed everything. On Christmas Day 2021, humanity launched a telescope unlike any music ever built. A golden mirror-lined observatory designed not merely to look farther but to see differently. The James Webb Music Space Telescope. A $10 billion collaboration spanning 3 space music agencies engineered to observe the universe in infrared light where music dust becomes transparent and the most ancient signals, music, still glow faintly across time. Almost overnight, the universe began to reveal secrets it had guarded for over 13 billion music years. Since becoming fully operational in mid-2022, Webb has not just refined our view of the music cosmos, it has fundamentally reshaped it. In just a few short years, it has completed hundreds of scientific programs, music, and returned an ocean of data surpassing what previous space telescopes gathered across decades. These observations have shown us that the universe is far more dynamic, more violent, and more surprising than we ever imagined. Today, we are going to journey through those discoveries from familiar worlds close to home to the very edge of time itself and uncover what James Webb is teaching us about music, our cosmic origins. Our voyage begins not in deep space, but right here in our own solar system. Neptune, music, long known for its serene blue appearance, is transformed music under Webb's gaze. In infrared light, the planet becomes ghostly and dark. Its methane-rich atmosphere absorbing nearly all reflected sunlight. Music, and yet, in that darkness, something remarkable emerges. Delicate rings, music, glow softly into view. High-altitude clouds shine with unexpected clarity. 14 moons reveal themselves, music, along with elusive ring arcs never seen before. Webb's vision turns absence, music, into revelation, allowing faint structures to step out of the shadows. But the telescope's attention soon shifted, music, to something even more extraordinary. A visitor from beyond our solar system. In August 2025, Webb trained its instruments on a comet unlike any other, an interstellar wanderer known as music, 3I Atlas. By analyzing its chemical signature, Webb discovered an unusually rich blend of carbon dioxide and water vapor, one of the highest ratios ever recorded. This object did not form around our Sun. Music, it was born in another star system entirely in regions cold enough for carbon dioxide ice to freeze naturally. In studying this single comet, Webb delivered profound confirmation. The fundamental ingredients of planets and potentially life are not unique to Earth's neighborhood. They are shared across the galaxy. From our backyard. Webb then turned its gaze outward, joining the ongoing search for worlds orbiting other stars. Thousands of exoplanets have already been identified, but many remained little more than shadows inferred from indirect signals. James Webb changed that. Just over 4 light-years away lies Alpha Centauri, our nearest stellar neighbor, music, a complex system of 3 stars. For decades, astronomers suspected planets might orbit the 2 sun-like stars at its center, but their overlapping glare made direct detection, music, impossible. Webb overcame this challenge using a coronagraph, a device that blocks overwhelming starlight, much like shielding your eyes from the sun. What emerged was astonishing. A faint point of music, light, the closest exoplanet candidate ever directly imaged, likely a gas giant comparable in mass to Saturn. Music, even more intriguing, simulations suggest it may follow an elongated orbit that, music, passes through the star's habitable zone. While the planet itself is unlikely to host life, its presence confirms something crucial. Planetary systems form even around our nearest neighbors. And where giant planets exist, smaller worlds and moons may follow. To understand how such worlds come into being, Webb peers into regions of raw creation. Nebula once photographed by the Hubble Space Telescope now appear transformed. The famous pillars of creation, sculpted towers of gas and music, dust, reveal thousands of newborn stars hidden deep within their columns. Music, jets of energized hydrogen burst outward, carving cavities and lighting up the surrounding material. These stellar births are anything but gentle. They are violent, chaotic, music, and breathtakingly beautiful. In the distant reaches of our galaxy, Webb discovered an enormous protostar, music, 10 times the mass of our Sun, unleashing colossal bipolar jets stretching across 8 light-years of space. These streams of matter, guided by powerful magnetic fields, slam into surrounding clouds, music, and create glowing shock fronts known as her Big Harrow objects. What makes this discovery exceptional is where it occurs. In a region with extremely low metallicity, closely resembling the conditions of the early universe. For the first time, we may be witnessing a modern analogue of how the universe's very first massive stars were born. As stars take shape, the leftover material around them begins to organize. Protoplanetary disks emerge, swirling arenas where planets and moons are assembled around a young exoplanet known as CT-Char. Webb detected a circumplanetary ring rich in complex organic molecules. This moon-forming ring mirrors processes that once shaped Jupiter's own satellite system. And remarkably, its chemistry differs dramatically from that of the surrounding stellar disk, offering scientists a rare opportunity to compare planetary formation across billions of years. Zooming music out further still, Webb has captured sweeping portraits of entire galaxies. In nearby spirals, glowing dust traces luminous arms-filled music with stellar nurseries, while ancient supernovae have carved vast bubbles into galactic structure. Across 19 galaxies, patterns emerge, revealing how matter circulates, how stars are born, and how galaxies sustain themselves over cosmic time. But to truly understand the universe, we must go further back to its earliest chapters. Using the natural phenomenon of gravitational lensing, Webb turns massive galaxy clusters into cosmic magnifying glasses, bending music, light from far more distant objects behind them. In doing so, it has observed ancient supernovae appearing multiple times across space and time, music, allowing astronomers to refine measurements of the universe's expansion. And finally, we arrive at the cosmic dawn. Music, Webb's instruments have detected galaxies so distant that their light has been stretched into deep infrared by music, the expanding universe. One such galaxy, seen as it existed just 300 million years after the Big Bang, music, appears far too large, far too mature for its age. Its existence challenges our most trusted models of cosmology. Perhaps the early universe formed stars at astonishing speeds. Or perhaps something, music, even stranger occurred. The birth of hypothetical dark stars powered, music, not by fusion but by dark matter itself. These discoveries force us to reconsider, music, the foundations of cosmic history. They remind us that, music, the universe is not obliged to conform to our expectations. With every observation, James Webb expands not just our music knowledge, but our sense of wonder. And this is only the beginning. Music, with decades of exploration still ahead, the James Webb Space Music Telescope continues to lift the veils of time, revealing a universe that is richer, stranger, and more alive than we ever imagined.